Welcome back to this new edition of Science Modernizers, where we are going to start a new session of solving the past Cameroon General Certificate of Education Board from 2020 advanced level precisely. And so we are going to begin with June 2020 question 1. So the question 1, the very first Roman 1 question reads that given that x plus 1 is a factor, it said x plus 1 is a factor of L of x, where L of x has been given as x cubed plus 6x squared plus 11x plus 6. Let's factorize L of x completely. So the meaning of factorizing L of x completely simply means we need to obtain the factors of this polynomial in its simplest product, in its simplest factors. That is, we need to decompose this polynomial into the product of its factors. So that's the meaning of factorizing completely. And here we are not required to solve for L of x equals 0, so we are just going to factorize. And if should in case you do not have this question, then we are going to drop it. You just go to the comment boxes, we are going to drop our questions there. So from here, what we can actually have is we need to divide this polynomial by the factor. So we are going to use the Euclidean division method, in which we are going to have x cubed plus 6x squared plus 11x plus 6, and here we have x plus 1. And so let's perform the Euclidean division. So x cubed divided by x will give us x squared, and x squared times x will give us x cubed, and x squared times 1 will give us x squared. And so subtract x cubed minus x cubed is 0. 6x squared minus x squared will give us 5x squared. So I will bring down my 11x plus 6. So 5x squared now divided by x will be positive 5x, and positive 5x times x will give me back positive 5x squared, and 5x times positive 1 will be positive 5x. And so I do the subtraction again. 5x minus 5x will be naught, and 11x minus 5x would simply be 6x. Yes, so I'll bring down my 6. So 6x divided by x will be positive 6, and 6 times 6x will be 6x, and 6 times positive 1 will be positive 6. And so here I have 0, 0. So it tells me that my L of x can be written as product of its factors as x plus 1 into x squared plus 5x plus 6. But now this particular term can still be factorized, because if you look for two numbers that will multiply, we have c, and when we add we have b. Those numbers are simply 2 and 3, because 2 times 3 will give us 6, and 2 plus 3 will give us 5. And so since the coefficient of a is equal to 1, and then we are simply going to have it as the product of its factors, that is x plus 1, x plus 2, and x plus 3. This is what was required of you for 4 marks in the 2020 session. And so we are going to go to the Roman 2 part of the question. The Roman 2 part of the question is asking us, or is telling us, that if you have a real constant lambda, then they said let lambda be a real constant, show that the roots of the equation, of the quadratic equation 3x squared plus negative 4 minus 2 lambda, all of that x plus 2 lambda equal to 0 are always real. So the condition for an equation to always be real is that the b squared minus 4ac should be greater than or equal to 0. So we need to verify the sign of a discriminant first of all. And so from here we can actually see that since lambda belongs to the set of real numbers, okay, so that's a very good condition which they gave. And so from here what we are going to do is simply to check the sign of a discriminant of delta. Call it delta, where delta is known as a discriminant of that equation. And so we have b squared, our a is 3, our b will simply be the coefficients of x, negative 4 minus 2 lambda, and our c will be 2 lambda. And so from here b squared minus 4ac will simply be negative 4 minus 2 lambda, all of that squared, minus 4ac 3 into c, which is 2 lambda. Are we together? So here I'm not going to put to anything that am I going to use an inequality, because I'm trying to check the sign. And so if it is always positive, then we are going to conclude that that the roots of that equation are always real. But if it is a contrary, then we won't be able to show, or we are going to have an opposition of that which they said. But since they said we should show that, it means normally it should be real, and so we need to show that and verify that it is real. So expanding this expression, here I'm going to have expanding, we are going to have 16 plus 8 lambda plus 8 lambda plus 4 lambda squared. Now at this level we have 4 times 3, which is 12 times 2, 24, so it will be minus 24 lambda. So this expression shall lead us to have, we write it in a quadratic manner, that's 4 lambda squared, 4 lambda squared, 8 lambda plus 8 lambda will be 16 minus 24, that will be minus 8 lambda plus 16, which is the constant term. That's what we are going to have. But 4 is a common factor everywhere, so I can have 4 into lambda squared minus 2 lambda plus 4. Are we together? Now from the theories of quadratic equations, we are going to complete the squares of this expression which we have. And from the theory of quadratic equations, if f of x is ax squared plus bx plus c, then completing the squares of this expression shall lead us to have f of x to be a into x plus b all over 2a, all of that squared, minus b squared divided by 4a squared plus c all over a. So that's the completing the squares of this expression. And so that's what we are also going to apply, say, in equation 1. So from there, applying it in equation 1, we are going to have 4 into, now our x in our case is lambda plus, so we write plus b is negative 2 all over 2a, a is 1, so you square all of this, minus b squared negative 2 all of that squared divided by 4a squared, 4 into 1 squared, plus c over a, our c is 4 divided by 1. Are we together? So this gives us, this simply gives us now 4 into lambda minus 1 all of that squared minus 4 over 4, which is 1 plus 4, and so from here we have 4 into lambda minus 1 all of that squared plus 3. Are we all in phase? So we clearly see that we have some terms like 4 lambda minus 1 squared and 3, but we know 4 is a positive number, it's greater than 0. 3 is a positive number, greater than 0, and lambda minus 1, all of that squared will always be positive for every value of lambda which belongs to the set of real numbers. And so since this expression, hence since 4 into lambda minus 1 all of that squared plus 3 is always greater than or equal to 0, then the roots of our equation are always real. Always real. Cure it. So that's what we have at the end of the day. And so that brings us to the end of this video tutorial. That is the first question of June 2020. So thanks for watching, and do not forget to click on the subscribe button to stay tuned to our channel. More videos shall be uploaded, and this year shall be completed in no time. So stay tuned. Do not forget to click on the subscribe button. Thanks for watching. Have a blessed time.